Hello students, in the last video lectures we talk about the Hamilton principle and the second form of the Hamilton principle. Today we will talk about Poincare Carton integral invariant. Okay. So here we will derive the formula for the variation of the action W in the general case. Okay. That means when we are considering the Hamilton principle, the initial and the final point, terminal point were the fixed, but over here we will not consider the initial and the terminal point fixed. We will consider it as the function of the parameter alpha as the other initial and the terminal coordinates. Okay, that means if T0 and T1 is also a function of alpha, and also Qi0 and Qi1 is also a function of alpha. Now we know that what is the action? You know that action is denoted by W, and that will be given by from initial T0 to T1 integral L dt, where L is the Lagrangian function. Okay, so in the same way, when we take this action and we will take the differentiating with respect to parameter alpha. So when we are doing delta of that W, that will be given by delta of L. Okay, so that will be delta of L. So how to open that delta of L? Let me do that. How they are using this thing on a blank page, let me tell you about this. So if they are talking about delta of L, okay, integral T0 to T1 dt. So what is L? L is a function of T, Qi and Qi0, right? So this is the function of this one. So if you open this delta of L, that will be given by T0 to T1, T0 alpha to T0 alpha, T1 alpha, you can write down, okay? I am just writing here T0 to T1, and it will be given by curl L over curl T delta T into that dt. Okay, plus again here I is varying from 1 to n, right? So you can say that will be given by integral T0 alpha to T1 alpha. It will be curl L over curl Qi into delta Qi, right? That will be dt plus curl L over T0 to T1 curl L over curl Qi0 into delta Qi0 dt, right? So this will be the terms. So when you do this integration, you say that will be L dt. Okay, that will be cancelled out, and that you can say that when you do the integration over this, so it will be just you got L delta t, and integration limited T0 alpha to T1 alpha. Okay, this is this one. Okay, and after that we will keep this thing as it is. This term will be kept as it is. We open this one by integration by parts. Okay, so when you open this by using the integration by parts, so you will get that. Suppose I am using this thing as it is. Okay, I am not writing, that will be there in the box. Okay, after that plus integration by parts over here, when it will be, so you will say that curl L over curl Qi0 into delta of Qi, right, and T0 to T1 minus integration of derivative of first, that will be d by t of what it will be curl L over curl Qi0, right, into delta of Qi into dt, right? So these terms will be left over there. So what I do here, I am using this value at T1 minus this value at T0. So value of the L dt delta t at T1, this will be denoting by value of L T1. Suppose it is denoting by L1, and delta t at T1, I am saying that is del T1. Okay, minus L at T0 will be L0 and del T0, right? And that term and that term, when you collect this thing, So you can say that delta of qi is common over here. Okay, so when it will be combined, so that will be curl L over curl qi minus of d by dt of curl L over curl qi naught. Okay, this term will be there, and after that this term is left here. So what is this one? You know that curl L over curl qi naught is nothing but this is pi. Okay, so I say that it will be pi into delta qi at t naught to t1. Okay, so if I apply the limit, that will be pi at 1, I say this is pi 1 and delta qi at t1, right, minus pi naught, you will say that that will be pi naught at t naught, and that will be delta of qi at t naught. Okay, so this value I have written over there, so you can check that. Now come to again over there, you can check that this value is used over here. Okay, so this is L1 delta T1 minus L0 delta T0 plus, I come take that integral, when you open that, after that, yes, this thing is overwritten over here, L1 delta T1 minus L0 delta T0, this is summation pi1 delta qi at t equal to t1. Okay, because the summation was there, I didn't apply the summation over there, you apply that, summation will be there, and at t naught that was pi naught and delta qi at t equal to t naught. Okay, I write down the terms, and the remaining integral I write down over here, where I combine the terms curl L over curl qi minus d by dt of curl L over curl qi naught. Okay, so when you combine this thing, so what we need here, actually when we combine this one, so we need this delta of qi at t equal to t1 and delta of qi at t equal to t naught. I want this one. So if you find out delta of delta of qi at t equal to suppose t lambda, and lambda is at 0 and 1, we will talk about. Okay, so delta of qi at t equal to t lambda, it will be given by the qi is a function of alpha. So this delta of qi can be written as curl by curl alpha of qi into delta alpha, right? Now we have the initial and the final points. Initial and the terminal points, you know that. What was the initial points? That was the t naught, right? And you know that that was the qi naught. Okay, alpha is nothing but that means qi naught t alpha, जहाँ पे t की वैल्यू क्या है t naught, and जो terminal point था that was at t1 and it was qi1 at t alpha. T alpha means that will be t1 alpha, right? So here we are talking about this thing. Okay, now if you have to talk about the variation of the terminal coordinates, and the terminal coordinates we have this one. So when we talk about this thing, so you say that qi1, suppose that I taking this one, qi1 is the function of t1 alpha comma alpha. Okay, now if you find out the variation of this one, qi1 variation, so how to find out? That will be delta of qi1, right? So delta of qi1 will be given by curl qi1 by curl t1 into delta t1. So I write down this thing, curl qi1 by curl t1, that is written as qi1 naught, okay, into delta t1 I have written over there, plus about the second variable, if I take curl qi1 by curl alpha into delta alpha, curl qi1 by curl alpha into delta alpha. So I say that this is curl qi1 by curl alpha at t1 alpha, so I just applied it, curl qi t alpha at t equal to t1 I write down. Okay, so if I use this thing, so now you know that curl qi by curl alpha at t equal to t1, what it will be? From here you know that if I take lambda equal to 1, so this value is equal to delta qi at t equal to t1. Okay, so over here we are placing this value, right, this as it is and this term is as it is. Over here this value is delta qi at t equal to t1 I write down. but I want here this value I want. If this value you want, I take this minus this. Okay, delta qi1 minus qi1 naught into delta t1. Okay, in the similar way we will find out the value of delta qi at t equal to t naught. So it will be given by delta qi naught minus qi naught delta t naught. Okay, so both the value we got. Now this value you have to place over here. Okay, delta, that was delta qi naught, delta qi1 over here, and delta qi naught what was below, that you have to place over there. Okay, so when I place this value, it will be pi1 delta, what is this one, that will be given by, let me show you this thing, given by this one. Okay, so that value will be given by pi1 into, you say it will be delta of qi1 minus qi naught into delta t1. Okay, and this, if I term about this thing, so if it will be pi naught, okay, that will be given by delta of qi naught minus qi naught dot, and that will be delta of t naught, right. So now these terms are there. So now you can check that over here, if you collect the terms with delta of t1, delta of t1 is present over here, so that will be, if a terms collect the terms, so it will be given by L1, and over here pi1 and into qi1 dot, so minus of, I take pi1 into qi1 naught. Okay, so into delta t1. Similarly, if I collect the terms for the delta t naught, I take common that minus, common here delta t naught, when you take that plus of L naught. Okay, and that will be, from here you can check, it will be minus of pi naught summation, sorry, that the summation you have to apply over there. I am just apply, so that means summation of what value, that will be pi naught delta qi naught dot, right. This value will be there into delta of t naught, right. Now remaining terms will be its first term and minus of its first term. So I collect it in the another bracket. Okay, that will be given by plus summation, that will be pi1 delta qi1, you can just understand that pi1 delta qi1 minus of, summation is same, minus of pi naught into delta qi naught. Okay, now this will be collected in the another bracket, and the remaining integral will be this one, this will be written over there. Okay, so from here we can check that when we collect these terms, you know that this is in the form of what? You know that the Hamilton function and the Lagrangian function has the relation, that will be summation of pi into qi naught minus of L. Okay, so if I take common minus, so you will say that value of this thing at t1 if I find out. Okay, so that will be pi1 delta summation pi1 qi naught 1 minus L1, that will be given by h at t1, that will be suppose h1. So that means this value over here, this value is nothing but minus of h1. So minus of h1 delta t1, and this value is minus of h naught delta t naught. तो माइनस माइनस ये हो गया माइनस h1 डेल्टा t1, ये हो जाएगा प्लस h naught डेल्टा t naught. डेल्टा टी नोट. ओके, अगर इन दोनों टर्म्स को मैं कलेक्ट करता हूँ तो इफ़ यू टेक द कॉमन माइनस एंड इट कैन बी रिटन एज, that can be written as let me rub this all, that can be written as minus of h delta t at t naught to t1, right. But we also have the term value of the summation. You also have this one, summation pi delta qi1, which I have written here pi1 delta qi1 minus pi naught delta qi naught. So when these terms are here, so you collect with each other. So if I open this thing, that was minus of h1 delta t1 and plus of h naught delta t naught. So when you correct these terms, so it can be written as, for one collect in one summation, that can be written as summation of pi1 delta qi1 minus of h1 delta t1, I'm sorry, delta of t1 and h1 delta t1 and minus of summation pi naught delta qi naught, okay, delta qi naught, that minus of h naught delta t naught. Okay, so these terms we just give the notation, these terms as value of pi delta qi minus h delta t at 1 minus value of this at naught t naught. Okay, so in the another words I just call it that value of pi delta qi minus h delta t, I call this as 0 to 1. Okay, so that means by using the same process we are using this value over here. You can check after substituting the value, so the same thing is written over here. Okay, after placing the value and using this relation, we got the formula for the delta w will be this one, right. So that notation, actually this thing, this value at t1 and minus value of at t naught, this value is called as summation pi delta qi minus h delta t at 0 to 1. Okay, so that's why I have written this summation from 0 to 1 and the remaining integral is this one. Okay, so what I will do here now, in the special case when for any alpha, if the appropriate path is a straight line, that means when qi as a function of t alpha kya hai, this is the family of the straight line paths, and you know that for the straight line path qi will satisfy the Lagrangian equation. If qi is satisfying the Lagrangian equation, so that means that will be equal to 0. If that is equal to 0, that means that integral will be vanishes over there for any alpha you take. Okay, for any alpha you take, that for that particular straight path this value will be 0. If this value is 0, so that means delta of w will be equal to this one only. So that will be given by over here, that for the variation of the action will be given by this one. Okay, now what we are considering here, now in place of the n plus 1 dimensional space, so what we are doing here, we are considering the coordinate as t naught and qi naught. Okay, we are considering this one, the coordinates of a point t1 and qi1, right, where I is varying from 1 to n, I is varying from 1 to n. So that means there were the n plus 1 dimensional space. Now I am taking that to n plus 1 dimensional space. That means one more coordinate will be there, t naught, qi naught and this pi. That means t, qi and pi will be the coordinate of the point. So that thing I am considering here, you can check. In place of the n plus 1 dimensional extended coordinate space, we are taking that to n plus 1 dimensional space. Okay, in which the quantities qi, pi and t will be the coordinate of the point. Okay. If in this space we take any closed curve given by equation, so we are considering suppose a closed curve C naught, I am calling this C naught. Okay. And this curve, equations of this curve is given by this one qi as qi naught alpha. For the C naught I am denoting it qi as a qi naught alpha and pi as pi naught alpha and t as t naught alpha, where alpha is varying from 0 to L. Okay. That means we have one and the same value. If suppose that the initial value is this one, suppose alpha equal to 0. Okay. So value, or we have the same point of the curve C naught when we have alpha equal to L. Okay. That means at alpha equal to 0 we start, and when we take the complete the whole curve, then again we come to at the point alpha equal to 0, but here the length becomes alpha equal to L. That means we have the same point of the curve C naught at alpha equal to 0 and alpha equal to L. Okay. Now we are considering this thing. We are considering the same way, taking each point on the curve C naught as the initial point. Okay. That over C naught, every point we are considering that point as initial point, and from that initial point we draw a straight line path. Okay. Now this straight line path will be uniquely determined, because for this straight line path there will be the Hamilton equations. Okay. Now for every point we will have a straight line path. If I take another point on C naught, then we have straight line path. If we take straight line, another point we take straight line path. If I take another point, we will take straight line path like this. Okay. So in this way we will take, for every point there will be a straight line path. So over here when we join these points also we will get some curve. Okay. So that means these are the trajectory for every point on the curve C naught. That will be the trajectories of the formed tube, you can say. Okay. And for the trajectories, that values are given by qi is nothing but that the function of t and alpha. Qi is a function of t alpha and pi is also a function of t alpha. And at C naught, when we were talking about C naught, the value of the curve at alpha equal to 0 and alpha equal to L, that was the same. So that means qi at alpha and qi at TL, that will be same. So that value will be same actually, and pi also t0 and pi at t alpha, that will be equivalent. Okay. So after this we have so obtained tube. So on this tube, if I arbitrarily consider some arbitrary curve, suppose that curve is C1, whose equations is given by, so the same manner we are saying that on this tube we arbitrarily choose some another curve C1 around the tube that have only one point common with each genetics. That means whenever you are considering this C naught, okay, and for one point of C naught you have at only one point at C1. For another point of C1 we have only, okay, that means for every unique point at C naught we have a unique point in C1 by using the genetics. So in the same way you see that the equation of that curve C1, that will be written in the form of qi as qi1 alpha, pi as pi1 alpha and t as t1 alpha, because we are denoting when we were taking that for the curve C naught. So there we apply that the note over there. Now we are talking about the equations for the curve C1. So that's where we are saying that qi as qi1, pi as pi1 and t as t1 alpha. Right. Now we will examine the x and w along the genetics of the tube from that C0 to C1. Okay. So around that tube I am talking about the x and w. So when we talk about that action which is given by W is T naught alpha to T1 alpha L dt. So for any alpha, because this W is also a function of alpha, okay, this W is function of alpha. So that means for any alpha, if we find out the delta of W is given by W dash alpha into delta alpha. That can be written like this. And delta of W we find out, in the above we find out delta of W will be given by summation of this thing 0 to 1 summation pi delta qi minus h delta t. So I use this one over here. Okay, so that means this delta of W will be given by this one. Now if we take the integration with respect to alpha and the limit is 0 to L. Okay, so when we take the integration within the limits 0 to L with respect to alpha, so when you take integration with respect to alpha, that will be W alpha. So W of alpha within the limit 0 to alpha, so that means W of 0 to L, that will be W of L minus W of 0. Okay, and right hand side that will be the integral within the limit 0 to L. So I write down then integral within the limit 0 to L. Right. So you know that at the point at the curve C naught, the point at alpha equal to 0 and the point at alpha equal to 1, that will be the same. So that means W of L at alpha equal to at L and alpha at 0, that will be the same. So that means WL minus W0, that will be actually same. So that will be equal to 0. If this is equal to 0, so you will say that this summation is equal to 0. So this summation, if it is equal to 0, I just separate the integral. Okay, separate the integral for t equal to 1, or you can say at the value at 1 and minus value at 0. So I separate this integral. So this is the integral 0 to L summation pi delta qi pi1 delta qi1 minus h1 delta t1. Okay, this thing I can say that this is the integral along the closed curve C1. So I will not apply this one, I just say that this is the integral of this value around the curve C1, around the closed curve C1. So I will say that this integral is integral along the closed curve C1 summation pi delta qi minus h delta t. And this value is the integral of this summation along the curve C0, closed curve C0. So this thing I have written over there, this is the integral along the closed curve C0 summation pi delta qi minus h delta t. Okay, now this is equal to 0, so that means this value will be the same. So what we obtained here, so we see here that integral, when we take that integral, that means when we are finding the action along the tube, so we got here integral along the curves, arbitrary curves along that tube, that will be the same. That means integral will not vary, there will not any variation in that integral when you are finding that integral along C0, C1, C2 and so on. Okay. So this thing is written that we got the same integral. That means this integral will be actually along C0 and C1 is same. That means this integral is invariant. I call this integral by I. Okay. So that means that will be the integral along an enclosed curve along that arbitrary tube that have that integral which will be the invariant. So that's why this is known as the integral invariant, or in the another words, you know, it is known as the Poincare Carton integral invariant. Okay. Now in the next lecture I will talk about the converse of the Poincare Carton integral invariant. So that was for the today. Thank you very much, class.